Welcome to What the Hex. This is an explanation of why there is hex code and why we use it and what it is and where it comes from. So hex is basically just a shortcut to show the value in a couple of bits of information. And when I say bits, I mean specifically binary digits. In binary, we just have ones and zeros. And most commonly, we have ones and zeros that are in bytes, which is a group of 8 bits. So I'm going to put a number in here that is binary. So moving forward from here, here's a byte, which is 8 bits. And if you read this out in binary, what you have is 11001010, and that's kind of unwieldy. So we can convert this to decimal, but it's hard to go back and forth between decimal because really what you want is the binary is what computers understand. So if you want to know exactly what you're using, then you use what the computer understands and not what humans understand. And yes, some humans understand binary, some humans understand octal, although most of them are dying off. And a lot of humans understand hex, because it is the shortcut. So hex is what you get when you use half a byte, which is called a nibble. So 8 bits is a byte, B-Y-T-E, and 4 bits is a nibble. Now I use a Y in the same way that I use a Y in byte for nibble, because that's the way that I was raised. Now, if you go on Wikipedia and you look it up, they actually use an I, but I'm more fond of the Y in nibble. Anyway, the difference between decimal and hex, as far as a hex digit is concerned, is in decimal, the values will run from 0, which is 0, 0, etc., up to 9. So you have a total of 10 different possible values in a decimal digit. For hex, since you're talking about 0, 0, 0, 0, it's actually more values, because 0, 0, 0, 0 to 1, 1, 1, 1 is a range of, using decimal values here, of 0 to 15. However, 15, anything 10 and over, actually takes 2 spaces, 2 digits, so you can't use that. So for the values of 0 through 9 from binary, you actually use 0 through 9, but you need different characters for the values of 10 through 15. And what we use are the values A through F. So 10, which is 1010 from binary, equals A in hexadecimal, through 15, which is 1111 in binary. So that's how you get all 16 values. 0 through F, 0 through 9, and A through F are your hexadecimal digits. So going back up to the example that we have at the top, we actually have a 1100, which is 8 for the first one, 4 for the second one, and then we have 2 zeros. And when we add these up together, we get 12 decimal. And 12 decimal, if we put the period here to indicate a decimal value, 12 decimal equals C hex. Now note that there are 2 normal conventions. There's more conventions. There's a third one that, to my mind, isn't all that popular unless you're a programmer, and I never pretend to be a programmer. But the normal way that one of the 2 normal ways, most common ways that you indicate hex is you put an H at the end, which means hex, just like you put a B at the end for binary. The other way is you use a prefix of 0x at the beginning to indicate hex, and then we would put a C here. Now, The values don't matter when you're writing it down like this or when you're entering it into the computer. For the most part, the case doesn't matter, whether it's uppercase or lowercase. I'm writing it here in uppercase in order to differentiate from other words, but you can certainly write it in lowercase and it would just look like this. And if you wrote more numbers on here, if we pretended what we were doing, we could write 9, 7, 3, B, 4, F, 2. Now that's a 32-bit number. It is 4 bytes or 8 nibbles. And so every nibble gets its own value. And then that would be on either side of the midpoint. So again, talking about this value up here, we can say what it is in binary, which is, again, 1100, 1010, and that's hard to remember. But we also said that the upper value is a C, of hex value of C, and the lower value being 10, and the 1010 is not an indication that it's 10, is A. So this value is CA, and now it's very easy to memorize it and to convey to other people what that value actually is. So again, it's just a shortcut between binary values when you're grouping 4 bits together and convert it into another indication of what it is. I did mention before that there is another shorthand that is not used very much today being the middle of 2022, but it was certainly used in the 70s and 80s of the last century, and that is called octal. So we mentioned before in decimal, we use the values of 0 through 9, and then we go on to the next digit. And again, the values can be 0 through 9. Octal is very similar to hex, but you only use 3 bits, 3 binary digits at a time. And this was useful when we had 12-bit processors where you had 4 octal bits or octal places that you could have. In this case, this is 12 bits. And if we just put imaginary values in here, 1, 0, 1, 1, 0, 0, 0, 1, 0, 0, 0, 1. So in this case, the values, because we can have 8 possible numbers with 3 bits using the 2 to the power of n, and n being 3 bits here, you get 8 possible values. The lowest value is always 0 because you start with 0, 0, 0. And then the highest value will be 7 because that's what 111 is. So this is your binary range for octal values, and converting to octal is 0 through 7. Now, because the highest value in octal is below the 2-digit decimal binary, your octal values can always look like decimal values because decimal goes from 0 to 9. You have to know that you're using an octal value. So in this case, looking up here, the octal 12-bit value is 5, 4, 2, 1. And there's nothing significant about it, just pick the bits at random. But this is what it would be in octal. So again, it's octal was a benefit similar to the way hex is a benefit, a shortcut for representing binary digits in encoding, and octal is just, or was just more convenient for those older devices. Since pretty much everything today is bytes and 16-bit words and 32-bit words and 64-bit words, those are all multiples of 4 bits, and so octal is kind of gone by the wayside. But if you find yourself getting a PDP 8 or PDP 11, whichever those machines last used octal and 12-bit processors, this is what you would use for the shorthand. And that's it. And that's everything that you need to know about what the hex. See you next time.
I don't even need...
That doesn't work. All that does is it syncs the two audio streams together and doesn't sync the video. So you have to be able to see it
I have
like,
both audios. These are two
like
audios.
that.
And you can't see that from that angle.
Okay.
Which is why it's
So we're doing another test.
No, this is the real thing. That's a lot of outtakes. I just realized...
Well, stop the videos.
I have you... Well, we're going to keep going. But I have you here... Wait, no. I have you here, and... This looks really funny from here. And I'm going to put the video on the side of you, because this is kind of...
Canted.
Has you... Like, this is the frame. It has you here. I want to put that here in editing. But you moved to this side when you went to go right. So that's the problem.
So you should have me centered. And I'm not sure I've moved from one side to the other. I haven't moved. I'm just basically going up and down. You have to say cut, being the director.
Oh, oh man. When you were writing the 5, 4, 2, and 1, I did not realize that it was completely out of frame. So I had to put it back into... Oh wait, I didn't stop.
Okay. See, now if the camera...
Maybe I should move... maybe I should move you... Maybe I should move you mid-shot. Okay, let's try that. Go. Oh, yeah.